My name is Nazir Khan from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada and around the world. This particular video is on chapter 22-3. It is the standard deviation that we are looking at. And when we look at standard deviation, we have to know some terminologies first of all. And the first one that we have going on here is terminologies. Population. Now, population means the entire set of data that you have. Say, for instance, you want a population of a city. You would not go and you want to know the population of the city, say, for instance, their height. You will not go and measure everyone's height, right? You would not survey the entire population. Now, that terminology, population, mean the entire set of data. When we look at sample is the subset of the population, meaning that you're going to take a sample of this population and then you are going to apply those results to the population. That means that you're making an inference from the sample to the population. And sample, the reason why we go for sampling is because it takes a shorter period of time, and for the most part it is inexpensive in comparison to surveying the entire population. So those are the two meanings. We have another meaning that we are looking at is the range, which is really a measure of central tendency. It is the difference between the highest and lowest value in your data set. The standard deviation indicates the spread of the data around the mean, right? And we'll see this in the formula itself. We will get familiar with a term such as variance, also along with the standard deviation. The less spread in the data, the more reliable the descriptive, the less spread in the data, meaning that if you have a graph, an XY plot, and you have a bunch of data points in there, and then you put a line, the best fit line, I should say, in between there, really that represents kind of the average of that. Now, the data is spread around that line, and therefore you could use the difference between that to get the standard deviation. And that is what this particular formula is about. You're taking all the x value and you're subtracting the x bar from them, right? So you're getting the difference between the actual value and your calculated value, which is the average of the x value. You're going to then square that, and you're going to sum all of them. That's the numerator of your standard deviation formula. This n minus 1, the n represent the number of data points that you've collected, and subtract 1 from it. And that accounts, the subtract 1 accounts for the degree of freedom. And we're not going to get too much into the degree of freedom, but that's only used for sample data, right? N minus 1 is used for sample data. We will not be dealing with very much with population data, but if it was a population, it would be a capital N, no minus 1, right? So that is where we're at with that. When we look at this next slide here, find the arithmetic mean of the number of the set. Subtract, this is the, I guess, the procedure for calculating your standard deviation. Subtract the mean from each one of the number of the set. Square these differences, and then you're going to sum the differences, and then you are going to divide by n minus 1, n being the number of data points that you have, and then you're going to take the root of it, right? And that will give you the standard deviation, right? The standard deviation, again, when we look at the normal distribution, standard normal distribution curve, we see that the average is 0, and then you go plus or minus to the right and left respectively. So, and then we have 1 standard deviation, 2 standard deviation, 3 standard deviation away. The standard deviation is your measure from the mean. A sample of 10 adults were asked to report the number of hours they spent on the internet the previous month. And the data, the result were there. So we have 10 data points, and as far as I know, they are in ascending order, so this is an ascending array. Calculate the standard deviation S from the sample. So from these data points, we're going to calculate the standard deviation S. Recall that the sample mean is 11. So if we were to add up all of these numbers and divide by 10, we would get 11. Now let's go and see it in a table form. We have all of the x values. We have calculated the sample mean of 11, and we're subtracting it from each one of these. When you subtract 11 from 0, you're going to get minus 11, and so on all the way down. Now this data point that I have here, this was a mistake in the data point, so one of the checks that I wanted to show you will not work in this, but we have to go through with the information as is. And again, like I said, you're subtracting 11 from your x value. If you subtract 11 from this, you could see that you'll get 3 rather than 2. So that's the mistake that's there. Let's go and take these almost, I'm tending to say variance, but you're vary from it, but it's not quite the variances yet. We're going to take these and square them, and square them, and square them, and then we're going to sum them all up. And this 917 really is the numerator inside of this radical sign, right? Or so then we have right, x minus x bar squared, and then we sum them, so then we have the numerator. N minus 1, well, we have a number of, I believe, 10, 2, 4, 6, 8, and 10, so we're going to divide by 10 minus 1, which is 9. And let's go to the next step of this, and it's going through the same steps that I've already explained to you. Find the arithmetic mean, subtract it from each one of the x values, and then we go to squaring those differences, and then we go to the next slide. Right, so we have now our numerator here. We have n minus 1, which is 9, so we have 917 divided by 9. We got to take the root of this, because this 917 divided by 9 here represent what we call the variance. When you take the root of this, then it becomes the standard deviation. And when we look at this, that is what we have. So the standard deviation is 10.1. Right? So this is a good example. It explains things very well, except then there was the one mistake in the slide. And I plugged this in here. Standard deviation s squared is equal to exactly what we had in the formula, but when we wanted the well, this is the variance here. When we want the standard deviation, we have to take the root of both sides, and this becomes just s, and this becomes the root of, right? So we are taking the root of both sides, and that is the variance. That is this part of it right here. Right? And then you take the root of it, you get the standard deviation. And if you have the standard deviation, you want the variance, you just square it, right? So it's back and forth. Find the arithmetic mean. This is the steps in calculating standard deviation. Subtract the mean from each one of the numbers, square the difference, find the sum of these squares, and divide by n minus 1. Find the root of that. You have the standard deviation. This formula that I'm sort of marqueing here, it is called the computation formula, right? It gives the same standard deviation as this formula here, the more normal formula, but this is called the computation. You're required to know both of them. This is the more common formula that's used for standard deviation. When we look at this, find the standard deviation S of the given numbers. So we have the numbers. I always like to arrange my numbers in ascending order, an ascending array. If I had to go and find the say for instance the median of that, then it's already there. Also, if I'm looking at frequencies, it's easier to pick out your frequency when you are already in an array. So when we look at this, we are not in an array here, and I don't believe for standard deviation we need to put it in an array, but I have the habit of doing that anyhow. These are the x values that are listed there. So we have 2, 4, 6, 8, and 10. 10, so when we add these up, we get 40 divided by 10 is 4 is your x bar, right, which is your average. And when we speak about the x bar versus, say for instance, the median, the x bar, the average involve each one of the number. When we look at the median, it just involves the middle numbers, right? If you have an even number of data points, then the two middle number. When it's in an array, you're going to average those. If you have an odd point, it is just one number that's in there. Okay, so then we went and take 4 away from 6, we get 2, and so on. So we're getting x minus x bar, and we're going all the way down. Now this particular example I don't believe have an error in it, but we'll see right away how to check to see if we've done that correctly. So we're going to square this, it'll become 4, square 1, it just stays 1, and so on. 3 squared will give you 9, and of course you summate that right there. This is this part of this equation. We still have to square it. No, we still have to divide it by 9 minus 1. Okay, so and then take the root of that. But when we look at this, just a check to see if you have your x minus x bar correct. If you were to sum this column, then you would have 0 at the end of it. And when we look at that, we have 3, 6, 8 minus 2 will give you 6, minus 3 give you 3, minus 3 will give you 0, and then 1 minus 1 will give you 0. So this column is actually summating to 0, and that I use that as a check to ensure that I've done things right. I've squared all of these correctly, so that's my check. But when I go and square these now, all of the negatives disappear, and you're going to have a number. So the summation of this column here will end up 0, and that's your check. And if you summate this, you will actually get a number because all of the negative became positive, and you're going to have a number. So when we sum that up, we get 42 right there. We know we have 10 numbers, and we're going to take those 10 numbers, subtract 1 from that 10, take the root of it, and we are home free. And I just wanted to show you S square means your variance. S square means your variance of this. It's not the standard deviation quite as yet. When you take the root of that, then it becomes the standard deviation. When we look at that, the standard deviation of this is 2.2. When we look at the variance, it'll be 42 divided by 9. Okay, and that's another example done. Let's go and look at another one using the computation formula this time. And remember that when we read the computation formula, we're reading from the inside out. When we look at this, what this really means here is you're going to take all of the x's and you're going to square them, and then you're going to sum them, right? In this case, you are going to take all of the x's and you're going to sum them, and then you're going to square, right? So you have to read from the inside out. Square the x's, sum them. Sum the x's, square them. And the n is just the number of data points, and we're dealing with a sample here, so that's what we are looking at. We have 2, 4, 6, 8 data points. So it's fairly easy to deal with the mean of that. I believe that the mean for this one might be... Okay, we don't have to deal with the mean because this is not the formula that we deal with the mean. We have to go and get the summation of x squared. We have to get the summation of x. So when we look at this, we list the data point, we sum it. Well, that's 40. So that will be plugged into that position, then squared. And then when we look at this one here, we're squaring all of the x's, 36, 25, 16, 49, and so on. We square them, and then we sum them. We square them, and then we sum them. Okay, so this one goes in here and this guy goes in here. We know that we have 10 data points, I believe, 2, 4, 6, 8, 10 data points. So this down here, this in bracket anyhow, will be 9 times 10, and that would be 10 right there. So we summate, we have 202, and we have 1600 when we square the 40. Alright, so then the last step of this is just plug these in here, plug in your 10s where they belong, and then we're on our way. We have this number right in here, times 10, minus 1600, and then we have 9, which is 10 minus 1, times 10, which will give you 90. You're going to divide that out, take the root of it, you have the standard deviation. Right? So this is the way that we calculate with the computation. We have two formulas. You're responsible for both of them. Okay, let's see what's coming. And here we have another problem, solving for the standard deviation using the formula of the number set. Okay, so when we look at this, we are given a bunch of numbers, 2, 4, 6, 8, 10, 12, 14, 15 numbers, and we're asked to find the standard deviation of it. Now, we are going to, they didn't dictate which one of these two formulas to use, the standard formula, computation formula, but let's go and see how to do that. We've listed the numbers. It seems like 2, 3, 3, 3. Yeah, it's in an array. We have the numbers here, and then we're going to go and find our x bar, which is down here. We have a sum of 69. We have 15 numbers, and we got 4.6 as our x bar. I'm going to subtract that 4.6 from each one of these x's, and these are the numbers that are the result of that. Of course, you're going to have to go and square these numbers, and before you do that, you should actually go and add up all of these and ensure that you have 0 as the sum, and then when you square them, it will come out with an actual number, so just be aware of that. So when we square these and then we sum them, now we have here the numerator right in there, right? And we know it's 15. We have the sum of the x's right here, and we have x squared, 3 squared, 9, and so on, and we have the sum of that also. So we have a few things. When we look at this here, which is this column, we have the numerator for that. We know it's 15 minus 1. The root of that will give you the standard deviation. With this second, the computation formula, we're looking at x squared sum. So we're going to go and look at the column. This is x squared, and the sum of it will be 351. And of course, the next one that we are looking at right here, I'm going to switch to a laser pointer here. The next one that we're going to look at right there, it's saying x, summate, and then square. So when we look at this x right here, and then you summate those, so you're going to square this number for that particular. We know that our x bar happens to be 4.6. We know our summation divided by 14, which will give you this formula here. It's going to be used. So we have 2.4, the root of that 1.5. Okay, and that is using this formula here. When we look at the second formula, the computation formula, we're looking for x squared sum, which is this number right here. We know that n is 15, and then we have, right for this one here, we have summation of x, then square. Summation of x is 69 squared, and 15 times n minus 1 will give you 14, and then you take the root of that. If you notice, these two are identical, so the two formulas give the identical result, but you use them in different circumstances in certain cases, right? So these are identical numbers. Standard deviation from both of the formulas are identical. Okay, let's see what's next. And